All right, so this video is going to cover dividing polynomials, including long division. So this is dividing. I can't write an I today. Dividing polynomials. All right, so let's start with some easier division ones. I don't know why this always is out of blur when I first start. Okay, so let's look at some easier ones. So dividing polynomials, let's see. So what if we have something like 15x squared and we want to minus 12x plus 6. So something like this, and this whole thing divided by 3x. So when we see this, we're dividing everything by 3x. Notice that the 3x doesn't have any plus or minus signs in it. So we can actually divide it into each thing individually, or basically break it up into fractions. So we'd have 15x squared over 3x minus 12x over 3x plus 6 over 3x. We don't like this method if it has a plus or minus because it's not effective. So it doesn't work. You don't get anywhere, but an ugly mess. So with this, though, when you just have the one term, you can actually then reduce each fraction. So 3 divides into 15 5 times. One of these x's will cancel with one of these, so I'm left with 5x here minus 3 goes into 12 4 times. The x's cancel, so I have a 4. 3 goes into 6, leaving a 2, and the x has nothing to cancel with, so we're going to have plus 2 over x. You got to keep that x in the denominator. So you could still have fractions, but that's reduced, and it's sure prettier than up here. So you can break up that 3x over every single term. Here's where it gets a little trickier. What if I have 2x squared, I'm going to sneeze, plus x minus 10, maybe, all divided by x minus 2. So we have x minus 2. If we broke this up, we'd put x minus 2 under all three. It's just going to make ugly fractions. We're actually not going to get it simplified, and it's not going to do us a lot of good. So what we want to do is set this up like a long division problem. So we're going to set it up like x minus 2 with our big long division, and we have to make sure these go down in sequence in descending order for the letters. We have x squared, then an x with like a exponent of a 1, then a number. Perfect. This has to go x squared, x, number, and it does, so we're good here. If it doesn't, I'll show you what to do on my next one. Okay, so here we are, and this is all set up in long division. The way this works is you look at this first term and the first term here. What would you times x by to get 2x squared? Well, we know we times it by a 2 and an x because x times x gets us x squared. So again, we just look at the x and the first term here and decide what do we multiply by to get there, and we put that up here. Then I take that answer and times it by the x, which better give me exactly what I planned, right? So 2x times x is 2x squared. Then you take the 2x times the next term, which is negative 2, so that would give us negative 4x's. So these better be the same exponent, same letters, or you can't do the next step. Then I, just like I do in long division, I figure out what multiplies or what goes in there, and then I subtract down. Subtracting down can be a little tricky. So what I do is I change the signs, and I will now use my signs I created and I circled and add them. So you can subtract them, but sometimes when you have double negatives and things like that, it's a little tricky. So these would go to 0, which was our plan. So 1x plus 4x would give us 5x's. So we subtract down or change the signs and add. Then I bring down the negative 10. And in my math lab, those of you that use my math lab program, this doesn't show you what they do. They don't even explain they subtract. So this is one section where the videos are kind of iffy unless they've changed them in the last couple months. Then from here, I bring down the next term and I look again at x, and this time 5x. X times what would get you 5x? It would have to be a positive 5. So 5 times x would give us the 5x. and then 5 times negative 2 gives us a negative 10. So these match, right? So when I subtract them, it changes the signs, and we can add them down, and we get 0. So there's no remainder on this one. So the answer is 2x plus 5. If you times this one and this one, you get this one. All right? So I factored out, or I divided out that term. Let's do another example of one with a remainder and with a spot. So what if I have a placeholder? Minus 2x plus 5, and I want to divide this by x minus 3. Okay, so I have 3x to the third minus 2x plus 5. Okay, then I'm going to set up my long division, and on the outside it goes x and then a number, so we're good. But up here, notice it goes to the third, then a x, which is a 1 power, and then a number. We're missing an x squared. So what we have to do is we have to put in a placeholder of 0x squareds. So now it's to the third, second, 1, or x number. You have to put the placeholder in, otherwise they won't line up to add and subtract, and it actually makes it really hard to do. So if your whole problem is falling apart, you probably missed a placeholder. Has to be out here too, because it's the same idea. They have to go in order. To be able to add or subtract, you have to have the same exponents with the same letters. So again, let's look at this one and this one. X times 3 would give us the 3, and then x squared times x would give us the x to the third. Then I take this times this, and I get the 3x to the third, and then 3x squared times negative 3 would give you negative 9x squared. Then I change my signs, and I add down. So 0 plus 9 of them is 9 of them. Bring down my next term, and I look, x times what would give us 9x? Well, it'd be a positive 9 and an x. 9x times x is 9x squared. 9x times negative 3 is negative 27 x's. Again, change your signs and add them down, so that makes 0. Negative plus 2, so negative 2 plus 27 is going to make 25x. Bring down your last term of a plus 5. X times what would make 25x? It would have to be a positive 25. 25 times x is 25x. 25 times 3 is going to give us, or negative 3 is a negative 75. Again, change your signs and add them down, so these go to 0. 5 and 75 make positive 80. So this is our remainder. And the way that we like to write our remainder, just like in a regular division, is we write it over our original. So in this one, we do plus, and then we say our remainder over our x minus 3. So 80 over x minus 3. So you just do a plus, and then you include the remainder in that. Okay, we could do this in function notation, and I could have called this function f and that one function g, and I divide them. So there's different ways that you could be presented this type of problem and still be able to get to the answer. All right, so that's it for my examples on long division. Be careful of changing your signs and adding them. That is by far the biggest mistakes people make.